Change one phone number and your database instantly disagrees with itself. That happens because the same fact got copied into 20 places and you only fixed a few. First, second, and third normal form are the three simple rules that stop it. No scary textbook talk, just deciding where each fact is allowed to live. Think of a spreadsheet. Each row is one thing, like one student, and each column describes it, like name or age. A relational database is just a bunch of these tables that can point at each other. Normalization is about deciding which columns belong in which table. In short, one table should describe one kind of thing and nothing else. Imagine writing your friend's phone number on 20 sticky notes. When the number changes, you fix a few notes and miss the rest, and now they disagree. That repeated fact is redundancy, and it is the enemy. Normalization's whole job is making sure each fact is written down in exactly one place. When redundancy sneaks in, you get three headaches we call anomalies. Update means you change a fact in one spot but not another. Insert means you cannot add a course because no student signed up yet. Delete means removing a student accidentally erases the only record of that course. In short, anomalies are the pain, normalization is the cure. Here is our before picture. Notice the courses column stuffs multiple values into one cell and the department repeats for every CS student. This one table is trying to be three tables at once. Watch how each normal form peels a layer of this mess. First normal form has one simple rule, no cell holds a list. So we split Anya's SQL and Python into two separate rows instead of cramming them together. It is like giving each item its own line on a receipt instead of writing them all in one box. In short, 1NF means one value per cell, always. Think of a key like the ID card that proves which row you mean. A primary key is one column that names a row on its own, like a student ID. Sometimes it takes two columns together to be unique, like seat plus flight number, and that pair is a composite key. Everything else is just a non-key column, plain data riding along. Hold on to these, the next two rules are entirely about keys. Second normal form kicks in when your key is made of two columns. The rule, every other column must depend on the whole key, not just part of it. The student's name depends only on the student ID, not the course, so it does not belong in the enrollment table. Here's the fix, pull name into its own student table. In short, if a column only needs half the key, it belongs somewhere else. Third normal form hunts down the sneaky middleman. If a non-key column depends on another non-key column, that is a transitive dependency. Department name depended on department ID, which depended on the student, so we split departments into their own table. Now the CS name lives in one row, not next to every student. Clean. Step back and look at the whole journey from one crowded table to three focused ones. Each table now owns exactly one idea, and the key stitches them back together whenever you need the full picture. This little map is what normalization actually buys you. The classic beginner trap is the comma separated cell, like tags equals red comma blue comma green. I did exactly that early on, shoved 5 phone numbers into one column, and spent an afternoon untangling it when one changed. Another mistake is bolting on column after column instead of asking whether a new table is hiding in there. When you feel yourself repeating data, stop and split. Now my honest opinion, 3NF is the sweet spot for almost everyone, and the higher forms beyond it are mostly overrated for everyday apps. Splitting everything into 100 tiny tables means every query joins 10 of them, and that gets slow. So for read-heavy dashboards, people deliberately denormalize, keeping a little redundancy on purpose for speed. In short, normalize by default, then relax it only where the numbers force you. Let me tie a bow on it. 1NF says one value per cell. 2NF says non-key columns must depend on the whole key. 3NF says no non-key column may depend on another non-key column. Say them like a ladder, atomic, whole key, nothing but the key. So here is the whole story. Redundancy causes anomalies, and normalization removes redundancy by giving every fact one home. Walk any table through 1NF, 2NF, and 3NF, and your schema will be clean and trustworthy. That's it. You have got normalization down. This bug took me 3 hours. Subscribing takes 3 seconds.